Hi, my name is Aleksander Buchowski. I'm co-founder at The Lion AI and senior engineer at MediaPress. Today I'm gonna talk about how ChatGPT really works and will change the field of IT and AI in a deep dive. Quick disclaimer, here we'll be talking on the example of ChatGPT, but the things we talk about really applies to any assistant model. So the concept of this presentation, the presentation is divided into three parts. In the first part, we'll talk about how ChatGPT really works, how it was created, and how you can create your own assistant model. In the second part, we are going to talk how to use ChatGPT efficiently. And in the third part, we'll discuss what are the implications of ChatGPT on the industry. So, how to obtain an assistant model like ChatGPT? There are 4 steps to obtaining an assistant model like that. First step is language model pre-training, where you train your language model on raw internet data. The second step is supervised fine-tuning, when you show the language model ideal responses. The third step is training the reward model, when you train the model that recognizes good responses. And the fourth step is reinforcement learning, when you use the reward model to teach language model how to generate good responses. So let's talk about the first part. What is a language model? Language model is formally a probability distribution over words or a sequence. So given the sequence or the words present in the sequence, the model tells us how probable the sequence is. Here we can see there is a sentence, the dogs run or runs across the park, and the model assigns different probabilities to different words that can fill the gap. So the model decides that the word run is more probable than the word runs, because the dogs are plural, so the word runs wouldn't really fit there. And the language model judges the entire probability of the sentence. There are many forms of language modeling. In the GPT family of models, we are using causal language modeling. That is the most simple form of language modeling, when the language model's role is to predict the next word in the sequence given the previous words. There are many more approaches to language modeling, such as masked language modeling used in the BERT family of models. But here we will talk about the causal language modeling. So why do we really care about the language modeling task? Well, firstly, it is often considered a pretext task. So we don't really care about the language modeling itself in a sense of assigning the probabilities, but the implications that arise from training a language model. So in order for neural network to accurately assign the probabilities of the next word in the sequence, or in other words, predict what the next word should be, given the most probable word, the model has to learn representations of the words and the meaning of the words. So the model has to understand what the words mean, what words are probable to come one another, and it needs to learn the semantic representations of the words in order to efficiently capture the language. And because the model learns the meaning of the words, their semantic representation, it can perform very easily different tasks, such as text classification, named entity recognition, and for example, sentiment analysis. Because if the model understands all the meanings of the words, it is trivially easy for the model to assign label to the sentence if the sentence is, for example, positive or negative. And here we can see on the example of GPT-3 model that the model trained just on the language modeling tasks can be used in a few-shot classification manner to perform other tasks, such as translation. So we give the model the prompt, the general task, description of the task, and a few examples, and then we ask the model to generate the translation of the new word. And we can see on the example of GPT-3 that the model is able to perform this task very efficiently. But all of this is just based on the text generation. So the model assigns the most probable word given the previous words, and because it can see all the examples and the prompt, it is able to accurately solve different tasks. And we can in fact model many tasks as a text generation. For example, sentiment classification, where you can give a prompt to the model, assign a label to the sentence, is it positive or negative, We can model named entity recognition. We can ask the model to assign labels to each word in the sequence. But all of those tasks are modeled as a language modeling task. So how to train the base language model? Well, firstly, we have to collect the data. And we can use, and it was often so, web resources such as Wikipedia or Reddit. And because we have an abundance of those web resources, such as blogs, articles, books, etc., it is very easy to create a dataset in a completely unsupervised fashion because we don't have to perform any labeling. There is no need for human annotation of the data. We just have to collect the data. In creation of one training example, we can just mask the last word in the sequence and ask the model to predict this last word. So this dataset can be created in completely unsupervised fashion and very efficiently. And given the evolution of GPT from models, each consecutive model has had larger and larger datasets. But we don't always want to collect all data sources as data quality matters. So we have to be careful to select only relevant sources of high quality. In this step, we also have to decide if we want the model to be general and use sources such as Wikipedia, books, and Reddit, or do we want the model to be specific and use, for example, only medical resources in order for it to capture the medical language. Here you can see an example breakdown of the training dataset when we have common crawl corpus, so datasets crawled from the internet, C4, that is also a collection of data collected from the internet, GitHub in order for the model to understand code, Wikipedia, books, some scientific articles from arXiv, and some technical questions from Stack Exchange. And this is example of a good general training dataset. The next step is choosing the model architecture. There are many options we can choose. Most of the current language models are based on the transformer architecture because it is able to model long-term dependencies very efficiently, and we can give it a lot of context. But if we choose the transformer architecture, there are many more hyperparameters we can choose from. We can choose larger model, but those larger models require more data and are more computationally heavy. So they won't run on any device. And we also can choose other hyperparameters such as batch size, learning rate, and for example, the number of words or tokens that we give to the model. The first step is the training the model. As we said, the language modeling task is pretty easy to model. You can just ask the model over and over to repeat to predict the next word in the sequence. And over a number of iterations, the model will get better. Here you can see example of them asking the model to generate Shakespeare, and after 250 iteration, it produces gibberish, but after 30,000 iteration, it is able to generate a good looking sample. But language modeling is not all that we need to create an assistant model like ChatGPT. Because language models are jerks, they are asked to predict the most probable sequence, not the most helpful one. And here you can see example of the text generated by GPT-3 model. The prompt given by the user is explain the moon landing to a 6-year-old in a few sentences. And instead of providing the explanation, as the user asks, the model generates other questions in a similar fashion, because there is a high chance that during its training phase, it has seen similar questions grouped together. So the most probable response for the model is to generate additional questions in the same fashion, not answer the user response. So we can't use just the language modeling task in order to create assistant model. This is where the second step comes in. We can fine-tune the model in a supervised fashion. So we can ask humans to play the role of a language model and generate responses that they will consider helpful. And then we can just feed the model still perform the language modeling, so predicting the next word in the sequence, but we can train the model on the responses generated by human. And this creates a small but high quality data set to fine-tune the model and align it with the assistant role. But uh, there are several problems with fine-tuning a model in this way. The examples just generated by humans are expensive because you have to ask each human annotator to create the example. This is a lengthy process and it takes quite a lot of time and resources. So we wouldn't be able to fine-tune assistant models like that efficiently. Instead, we can train a reward model that mimics the human behavior and is able to judge if the sample generated by a language model is good or bad. Uh, this model is very easy to train compared to a generation model because it is essentially a regression problem when we have the input sequence and we have to assign score to it. And we can train this reward model and later use it to fine-tune our base language model. Here you can see example of how the reward model is trained. For example, given the prompt that we discussed before, the reward model scores the completion generated by GPT-3 in form of generating another similar questions very poorly. So, for example, minus 1.7 points. And it's given the same prompt but different completion, the model scores this response very highly because the model generated in fact what the user wanted. So we can assign it a score of +2, for example. And during the training the reward model, we have the same prompt repeated several times and different responses sampled from the language model. And humans, for example, can judge the responses if they are good or bad. And then we can train the reward model, so essentially a regression model, on the labels assigned by humans. And this is quite an easy task for the neural network to perform. Then, when we have the reward model that is able to accurately judge if a completion is good or bad, we can use the model in a reinforcement learning fashion. So we can, again, ask the model to generate several completions based on the same prompt, and then we can score those completions using the reward model. And once we have our data set of the prompts and different completions to the same prompt, we can again fine-tune the base language model on the language modeling task. So we still ask it to predict the next word in the sequence, but we assign weights to different samples. And if a completion is judged poorly, it has, for example, negative sample, so a negative score. So the model is asked to not to generate completions like that. And if a completion has high score, the weight is higher. So the model is asked to generate completion like that with higher probability. And it is, in fact, a very efficient process because by training the reward model and then using it for reinforcement learning, we don't need the human annotators to judge every response, and we can, in fact, train a subsidiary model to mimic the humans judging the language model. And those are the steps that were taken to train ChatGPT. Uh, so just a quick recap. First, in the first stage, we train a general language model that is trained on the task of predicting the next word in the sequence. Then we perform supervised fine-tuning when we show the model ideal responses generated by humans acting as the assistant model and showing the model what it should be generating. In the third step, we train the reward model. So we train the neural network to judge how good a completion is. And in the fourth step, we use the reward model to efficiently fine-tune the model in a reinforcement learning fashion. And as a result of this process, we can have a model that is not only good at predicting the next word in the sequence as a general language model, but it can also predict helpful responses that follow the instructions of humans. And in fact, we can use this process to train other assistant model. So uh, there isn't anything special about ChatGPT, and in fact, other assistant models such as Open Assistant already emerge that are trained in this fashion. And the reward model and supervised fine tuning is the data sets for these tasks are trained by the with the help of community. So once we have this assistant model that is able to follow user instructions and generate helpful responses, what can we use it for? Well, for example, we can use it for summarization, when we can ask it to generate shorter text based on longer text. We can ask it to provide transcriptions. We can ask it to summarize article, reports, etc. We can use it for brainstorming when we ask the model to give us several ideas, for example, for a new product and come up with a new concept. We can use it for synthesizing, for example, generating insight and takeaways from text. And we can use it for coding. So for example, we can ask the model to generate a simple function. We can also, as was shown before, replace several natural language processing tasks by the assistant model. So for example, we can perform name entity recognition in a sequence-to-sequence fashion when we, for example, generate a prompt that given this text, extract all persons that appear in this text, and the model will generate a list of persons. We can perform information extraction, so again, extract key concept from the text. We can perform summarization, translation. We can perform conversational AI when we can ask the model to play a certain role, for example, a helpline assistant, and we can give it in the prompt, in the context, for example, instructions how to do something, and we can ask it to explain it to the user, and the user will ask questions, and the model will provide answers such as helpline assistant. We can use it for style transfer, for example, to regenerate text in a different style. For example, more funny, more professional, more informative. And we can also use it for text classification, so sentiment analysis, intent detection, and many other NLP tasks. So the key part in using the ChatGPT-like model to perform those tasks is the creation of a good prompt. So as everything is modeled as a sequence to sequence, the input sequence that we give to the model is really important. And for example, choosing specific words or specific phrasing can affect the outcome of the model and its overall accuracy. So the question emerges, how to create a good prompt? Where there are several techniques for creating prompts and so-called frameworks. The first framework is called RTF, this is what stands for Role Task Format. In the first part of the prompt, we can give the model a role. So for example, we can say that it is a critic, it is an expert, and as research shows, encouraging this model by telling it that it is, for example, a world-class expert or renowned critic actually increases the accuracy of the model. In the second step, we give the model a specific task. For example, summarize this article, generate this article, stuff like that. Essentially the task that we want the model to perform. And in the third part, we define the output format. So for example, if you want it in CSV, in code, in tables, in bullet points, and in stuff like that. And this format really matters because in standard fashion, the assistant model has trouble following the format that we want to specify, but there are ways to define this format, like Pydantic model, that is models that are integrated in the LangChain library that we'll talk about on the next slides. The second framework is called CTF, which stands for Context Task Format. And the difference between this framework and the previous one is the context part. So in the first part of the prompt, we want to define the context of our task. And it has been shown that defining this context, so for example, telling the model that we need not only that we needed to generate an article, for example, but we want this article to appear on a website that talks about our product, that is this, and that. It really helps to ground the model in the specific task, and in fact, it generates the model generates more accurate responses. And the second and third part are essentially the same. So we state the specific task, and later we state the specific format. The third framework that we'll talk about um, is quite more complicated in a sense that it has more parts. In the first part of the prompt, we ask the model, we tell the model the persona that it takes. So, for example, it's a critic, it is a content creator, it is an expert in some field. In the second part, we state the task. In the third step, we define the steps necessary to perform this task. So we not only ask the model to, for example, generate an article that appears on a website, but take, we want to tell the model specific steps. So make sure this article has this, and that. First, generate the title. Second, generate table of contents. Third, generate the first paragraph about this, and so on and so on. Then we provide the context. So as we discussed before, grounding the model in the context of this task is really important. And the next step is to provide several examples of the model. And we already talked before about this so-called few-shot learning. So if we want the model to perform a specific task, for example, translation, it is beneficial to give the model a few examples of translation, for example, from English to French. And it is more and more important if our task is more complicated. So for example, if we want to do information extraction, we should provide the model with a few samples of the information that we want to extract. And so on with the, for example, text classification. If we have like a specific classes for the classification tasks that are not well known, like sentiment analysis, where the classes are positive and negative, but are our like own custom classification task, then it is really beneficial to provide the model with a few examples. For example, text like that should be classified as this class, and another text should be classified as another class, and so on and so on. There are also frameworks that automatically select best few examples based on the similarity of the input text. So we can have, for example, we already have a few labeled examples or a few hundred or thousand in our database because we maintain it. And we can ask the model to select useful examples for this specific input data based, for example, on the cosine similarity between the vectors in our database and the vector of this new sample that we want to classify. And the last part is the format. So as we stated before, we want to tell the model what format to follow. There are several limitations of assistant models. So the first most important one is that ChatGPT isn't capable of identifying its own mistakes. And this is really important part because with another machine learning models, for example, when we perform classification, we have scores that tells us how how confident the model is in a certain classification. And we can set a threshold where, for example, that over the 0.7 score, 70% score, we want to return this information to the user as certain classification. But we have the ability to choose this threshold, and we can calibrate the model to follow, for example, linear probability. But with ChatGPT, this is not the case. Even in any sequence-to-sequence model, the model will always generate the sequence, and we have no idea of knowing how sure the model is. So the model is prone to hallucinations and making up facts and stuff like that. But the most important part is there is no way to distinguish between real information and hallucination. The second limitation is that ChatGPT is offline. There are, of course, plugins that will deal with this problem, but in its raw form, ChatGPT has no access to the internet and can only use facts that are in its training database that ends in 2021. ChatGPT has no memory. We are talking about the so-called short-term memory of or the context length that we are able to provide to the model. There are differences between the model sizes, and there is no public information about the contents of ChatGPT, but people assume it is 8,000 tokens. So we have to formulate the entirety of our task in this 8,000 words, and there is no way to, for example, give the whole database to the model. And ChatGPT doesn't perform reasoning, so we have to remember that this is a probabilistic model, so it returns the sequence that is more probable, and it is all based on the training data set and the probability of different words appearing together in the training data. There is no like logic internally performed or any mathematical calculations inside the ChatGPT. And solution to those problems, are tools like LangChain that allow the language models to use different resources. So for example, the model is able to decide itself that it needs to perform a web search, um, offload this web search task to a, for example, Python function that performs the search and returns the results. And the model can then have the results of the web search as the context and is able to perform the next step in the task. And tools like LangChain also provide the model with databases, with similarity searches, and things to enhance its capabilities. So in the last part, we'll talk about the implication of assistant model. And we'll, of course, talk about it in a short to mid-term because it is really hard to predict what will happen like in 10 or 20 years. So there's like a lot of concern that even when the ChatGPT is able to generate code, it will replace software engineers, and there will be no need for software engineers anymore. And we'll try to answer, will it happen in a short term? And if you want to discuss it, we have to firstly define what software engineers really are. And software engineers are translators because they translate the specifications of the client to the code that the computer can understand. And over the years, the type of code changed. So we we as software engineers translated the specifications to machine code, then low-level programming languages such as C, then high-level programming languages such as Python. And the target of the translation changed over the years, but it was still a translation job. And with the rise of language model, it appears that we have moved maybe to the um, to the another layer of abstraction where we don't translate the specifications, what the client wants, to computer understandable code, but to a natural language format that then ChatGPT can understand and generate the code itself. But the role is still vital because we still have to know what tools to use, what language models are good for text generation, how to perform the prompt engineering, how to define the input in a way that ChatGPT can understand it, and how to translate the vague description of the product given by the clients to a specific queries to ChatGPT. But the translation job is still there. And in fact, the no-code or low-code platforms already existed. This is nothing new. And in fact, the research shows that low-code developers are actually happier and make more money than high-code developers. So, for example, 72% of low-code developers users make 100,000 US dollars compared to 64% of high code users. And 42% of low code users are highly satisfied compared to 31% of the high code users. So the tools like that emerge and they don't make the software engineer's job worse or less lucrative. And The first most important thing is that language models can exist in a vacuum. So we discussed that at least in the short term, the models, assistant models like ChatGPT, still need things like databases, authentication, security, and external, for example, search tools um, to perform those tasks efficiently. And those tasks will still be there. And if a language model is used by more and more companies, and it may lie at the heart of your product, but you still need uh, to provide it with external tools for the language model to use them efficiently. And we can also ask ourselves that will the ChatGPT replace ML engineers? And we need to understand that ML engineers are translators too. So we do translate the specification of the client, project manager, etc., into the models. But the models are code in the end. And most often our clients don't care about how the stuff really works. Is it innovative? Does it perform research? But they only care about if this works. So our role is no different in the business perspective than software engineers. So we still can use high-level tools like ChatGPT, etc., to perform our tasks, but there still needs to be someone that translate the specification to the format that those tools can understand. And again, language model can exist in the vacuum, and there are still many more machine learning problems that needs to be solved. For example, image generation. The newer versions of GPT models like GPT-4 can understand image as input, but they can't generate the images themselves. We also have to perform things like automatic speech recognition if we want to communicate with the language model by voice, and then speech synthesis if we want the language model to respond to the users. And these are just a few examples of the machine learning problems that can be really solved now with language models or assistant models that are still there. And moreover, ChatGPT and models like that have troubles communicating with niche languages such as, for example, Polish. The model performs quite well, but it is still less accurate than in English. So things like non-mainstream languages, things like specific domains like medical domain, legal domain, stuff like that, there's still a lot of research to be done in those fields. And prompt engineering is also a viable career path nowadays. Of course, it can be less glorifying than the ML engineering, but more and more prompt engineers are needed. There already are sites that offer certification of prompt engineering and prompt engineering courses. And as we discussed before, it is not a trivial task to generate a good prompt that the model can understand. So we can suspect that there will be more and more roles of prompt engineers. And lastly, we can ask in general, will ChatGPT replace your job? Because there are programmers, there are ML engineers, but there are also other jobs like content creators, like marketing specialists, that that it would appear that ChatGPT is prone to replacing those jobs. And we can answer this by the quote of Kurt Langlotz, a director of Stanford AIME, that AI won't replace radiologists, but radiologists who use AI will replace radiologists who don't. And this can be extrapolated to any profession. So we can suspect that ChatGPT won't replace all content creators. Of course, the market may be smaller and there will be less and less of those roles needed, but it won't replace them entirely. But for example, content creators that use language models and tools like GPT will replace those who don't. And we can also say that ChatGPT will create a lot of jobs, as we discussed, prompt engineers, but also testers, as we discussed, the language models aren't really accurate, and in a sense that they can't state that they're not certain and provide us with the confidence scores. So a new language model that will be used in production has to be extensively tested in a variety of ways that it won't hallucinate and it won't give the user information that we don't want it to give to the user. So, for example, it can be misleading about our company, about our product. It can be offensive to a user. We have to account for all those examples and perform lots and lots of tests for the language model because before we can safely use them in production. Also, domain experts, mm, as the this is the same case as for the testers. So if we, for example, were to use ChatGPT like model in the medical domain, we will have to consult with a lot of doctors to make sure that the stuff it generates is accurate, is not harmful, and can be reliably used and given to the end users. And um, I suspect that a lot of domain experts from different domains, such as legal, such as medical, will work together with prompt engineers, with machine learning engineers to provide the to create solutions for those areas. And for example, a viable career path as a doctor in the future, maybe for example, a domain expert for AI companies. And also there with the wider use of language models and assistant model, a lot of questions emerge concerning ethics and compliance, and we can suspect that there will be need for a more regulation, more ethical debates. So we will certainly need people that can take on those challenges. So that's all. We now know how models like ChatGPT really work, how to create your own model like that, how to use those models efficiently, and what are the implications of those models. So a few takeaways from this presentation. We have to remember that ChatGPT is nothing more and nothing less than a language model that is optimized for generating the most probable word given the previous words that is trained on the data set that was provided to it. It doesn't perform any reasoning, any for example, mathematical calculations where we give it a math problem. It just predicts the most probable word. Um, and ChatGPT and other language models would definitely affect many fields, such as content creator, art programming, and consulting. We discussed a variety of use cases of language models, and ChatGPT and any assistant model can definitely affect a lot of jobs, but it will be up to you if it will replace you. And ChatGPT and other assistant models will also definitely create a lot of new jobs. That's all from me. Thanks for watching. Remember to rate this presentation and leave your questions in the section below. If you are interested in more content like that, you can follow the Lion AI. Thank you very much.